Good afternoon, guys. Here is the video that goes with your study guide. I am going to go through it relatively quickly. You should have some idea of what's going on. Here we go. Number one was super simple. This is going to be just like it is on the test. I'm actually going to borrow something from this. All right. I'm going to start cutting vertical lines. Which relation is a function? I'm going to put vertical lines through this stuff. That vertical line follows right along, and I know it's not perfect, but it follows right along. It would lay right on top of that, number one. So it cannot. Put an X through it. That was horrible, but you understand the idea. I'm going to put a vertical line through this bad boy, and it cuts this one in two spots. If I put a vertical line through this one, no matter where I put that vertical line, it's only going to cut this in one spot. And last but certainly not least, letter D, this vertical line cuts through this in two spots. So once I get rid of this, the only function here is this guy here. Okay? Awesome. Thank you. It looks like a sine wave, a negative sine wave, if you look at it. That's for later. Okay? Given the function, so I'm going to write, vertical line test. That's how we solve that. Okay, use the vertical line test. All right, let's move on to number two. Let me grab a different color so we're not using the same color all the time. All right, number two. This is super simple. You're given a function, x squared minus 2x. The function of x equals x squared minus 2x. Find a function of 4. That means everywhere you see an x in this function, write in a 4. So here's our function, f of x equals x squared minus 2x. All right, so we'll rewrite this. F of 4 just equals whatever I'm putting in there squared minus 2 times whatever I'm putting in there. So, oops. Let me fix that real fast. I don't want you to have to do that. I'm going to use a different color. What am I putting in there? I'm putting in a 4. There it is. There's the 4. All right? So 4 squared is 16 minus 2 times 4 is 8. 16 minus 8, just 8. There's our answer, letter H. Okay? Sound good? We'll move on to the next page. Here's number 3. Number 3 says, find the 0 of this function. That means solve this function for 0, negative 2/3 x minus 12. Okay, well, let's fix this. Let's add 12 to both sides. Plus 12. Now we have 12 equals negative 2/3 x. Dividing by a fraction is multiplying by the reciprocal of that fraction. And we want to solve for a positive variable. So we're going to multiply by negative 3/2. Halves, so-called. There we go. Negative 3/2. All right, so this and this, when we multiply, we get one lonely little x. That equals negative 3 times 12 is negative 36 over 2. Hey, that's pretty cool. Divide negative 36 by 2 and you get negative 18. Sorry about that. Not so pretty, but You see it, right? Oops. There it is, letter A. Okay, number 4. Number 4. Here it is. This says, what is f of 2? Okay, we replace the x with negative 2 for this piecewise function. There are two different functions, right? So this is put in negative 2. Now, which one will I put it into? It's got to be the bottom function. It's got to be this. Why? Because there's that equal sign there. That equal sign right there tells me that this is part of this. Okay? So go ahead and put it into the bottom. X cubed minus 1. Okay, well, now I'll put in minus, oops. Oh. Sorry, minus 1. I hit the button. Okay, let's go ahead and put in our negative 2. Sorry about that. Negative 2 cubed is negative 8. That's what calculators are for. But Mr. Sokol knows how to do this in his head, so we have a total of negative 9. That shows us that it's J. Woohoo! Moving on. Got 3 problems here. Which is an odd function? Now, according to Sokol's definition, both f and g are odd functions. But the truth of the matter is this negative right here messes everything up. This negative here makes it impossible to get an inverse, all right? So the truth of the matter is it's this guy here, okay? I want it to be like a parent function when you see it, so that is the only way. So I'm going to say 6. Parent needs to be a parent function, no constants or other terms or other terms. Sorry I'm writing slanted, but I'm trying to do this as quickly as I possibly can. I don't want to keep you in this video forever. It gets to be boring after a while. Let's do number 7. Number 7 says, which function has a removable discontinuity? And we found that if we put this function into a calculator, it was linear. So A is linear. C, also linear. It was really, 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 really flat and just heading toward there. It did jump up because we couldn't put -3 in. Okay, and so that doesn't have a removable discontinuity. This one, letter D, is cubic in nature. There it is. Okay, but letter B is the only one that we could factor, right? Letter B equals this x squared minus 4 you should see as a difference of squares. X plus 2x minus 2, and then that's all over x plus 2, right? Well, these two things can cancel out and we'd be left with a linear function, right? If you just put x plus 2 in there. And if you do put this into your calculator, you're not going to see that removable discontinuity, that hole in this function. But there is a hole in the original function at x equals -2. Because if I put a -2 in here, I get out a 0 for my denominator, and that doesn't exist. So this guy right here has one tiny hole in it. You can find a limit for it, but that's down the road. Here, let's just think of this. We do have a 0 for that function, and it's not just an asymptote like in letter C. It's an actual hole in the graph. You'd have to zoom way in or look at your table when you put this function into the calculator, and you'll see every other number on that table gives you an output, but you'll see the word error. Woo! Error at -2 on your table. Okay, you'll see that. Let's move on to this. I've taken way too long. This is letter G, and it just gives us, a nice, easy -3/4. This is the answer. I'm probably going to eliminate this. It's not very exciting, okay? But it is G. We did go through this in class. Let's move on. Number 9. Here we go. Remember what I talked about. Put this function into your calculator, and I have put it into my calculator. I'm not going to display the calculator right now. I'm just pulling out the calculator and talking at the same time. So I have these functions, right? And I've hit my table function, all right? So I have a table here of this first function. I got to get rid of this. Pardon me. Need that to go away. Sorry that jumped up on you. So I put this function, let me grab a different color because you're tired of seeing the same color. I put this function, p of x, into the calculator. And I need to know what's going on from from 4 to 10. All right? And once I find out what's happening from 4 to 10, I can see where that relative maximum is. So if I look at 4, all right, if I look at 4 in the table, I have a value of 86. So at 4, I get 86. At 5, I get 95. At 6, 7, 8. At 5, I get, 48. Sorry. 86, 95. 6 is 48. There we go. 6 is 48. So I've turned around, right? I was going up, and now I've turned around and come down. So 95 is the highest number I see on this table. So this would be the closest to a relative maximum of this function. All right? I don't have to look at the rest of them. I know that this is the relative maximum because if you look at the rest of the numbers, they go down. They decrease. All right? So let's look at number 10. Number 10, you put the function in the calculator again. And what you're going to do is you're going to look at the table again. And what you're going to do is you're going to find from 3 to 4 seconds. So in your table, at 3, you get out, just grabbing my calculator, you get out 72, right? And at 4, you get out, if I'm not mistaken, 32. So I want to find my change in altitude, right? y2 minus y1. y2 minus y1 is 32 minus 72. And that gives me negative 40. And my change is 4 minus 3. 4 minus 3, which gives me 1. Okay, well, negative 40, is that an answer? You're absolutely correct. That's this guy right here. Negative 40 feet a second. Now, I'm going to move on. Got to move on. We're getting super, super, super close, right? 3, probably 6 more. Yee. All right. Let me jump up here. All right, which of the following is the result of a graph being expanded? Expanded means we expand. Means multiply my slope or whatever. Means multiply my function by something that's not fractional. All right? So really and truly, I could get rid of any of these things because they have fractions. All right? And then flipped over, multiply by something greater than 1. Okay? Multiply by greater than 1, and then to flip over x-axis, make it negative. And what do we have? This is negative and multiplied by 3. So there it is. So 13, parent function is this. Remember, oh my gosh, we went over this in class. Here we go. And I'm just going to give you the rules. Look, if it's inside the parentheses, inside the parentheses, if we're adding 7, we move left 7. If we're subtracting 7, move right 7. All right? Now let me change the color because I don't want you guys to freak out. Outside the parentheses, if we are adding, let's say 3, we would go up 3. If we were subtracting 3, we would go down 3. Sorry about the writing there. Looks like clown. That's me, clown. All right, and last but certainly not least, talk about absolute value functions. If you put this into the calculator and use this, you will get this function out. I want you to recognize that this function would look like this guy, but since you can't get a negative value out, it has to have been flipped over the x-axis, and this is what you get out. This is the absolute value of x, not what we're looking for. So that goes away. This, just a parabola upside down. This is x cubed, but not the absolute value because there's a negative section. Okay, so that's the only one that works. Moving on. Oh man, I'm missing something and I don't know why. Let's see if I can get there. Help, help, help. Let's see if I can do this. No, I'm missing something. I'll have to add something on to the problems at the end. Okay, here we go. This is just addition. 15 is addition. So 15 just says add this to this. Okay? 15 means add the f function to the g function. So x minus 3 plus 2x minus 4. I can put these things together. I have like terms that I can put together, right? The x and the 2x. If I add those together, I get 3x. All right? Negative 3 and negative 4, when you add them together, you get negative 7. Is this an answer? Yeah, it's letter A. Okay? Looking at number 16, I didn't give it enough space. I want you to look at this. If you have a 20% off coupon, what percentage are you paying for your pizza? Whereas C is the cost of the pizza. All you had to do was look for C is 80% of the total cost, right? Because we had 100 minus 20%, which gives me 80%, right? Times the total of the pizza. Good? All right, moving on. Fog. We love it. We love our fog. This is 17. Woohoo! All right, here's my f function. That is x squared plus 1. And my g function. Let's use this. G of x equals 2x. Ready? Jeez Louise. Fog f of g of x equals, I'm going to put the parentheses out and the square plus 1. Now I'm going to change my color and put in 2x. Square this sucker. 2 squared is 4. X squared is x squared. And then keep my plus 1. Is that one of our answers? Yeah, it's right there. It's letter D. Okay, we good? All right. What I'm going to do is go back to this original layer. I'm going to close this out. And I'm going to do the last couple. I don't know why I didn't put their screenshots on there. What I'm doing is buying some time while I find that actual page. Give me one moment while I turn to those. Oh. Number 18 says, find the inverse. Find the inverse of, let's go here, change the color. Let's say f of x is 2x plus 9, 2x plus 9. What do? We write it out as y equals 2x plus 9. Then we change our y's for our x's. So x equals 2y plus 9. Now we solve for y, so we're going to subtract 9 from both sides. You can't put x and 9 together, so it's going to be x minus 9. These go away. Equals 2y. Then divide by 2. Divide by 2. Divide by 2. X minus 9 over 2 equals y. That's our inverse. Y prime is x minus 9 divided by 2. The last one, this is it. The be all and end all. I'm going to section it off. There it is. Let's change the color. Let's get to work. The last one I want you to talk about is number 19. I lied to you. Number 19. 19 says, which of these has an inverse that is also a function? Okay? If you look at letter A says the absolute value of x. That is a V shape, right? Well, if you switch your y's and your x's, this V shape becomes a V shape going this way, right? Now, we already knew that it didn't have an inverse because it didn't pass the horizontal line test. But if you use this shape, if you use this inverse, does it pass the vertical line test? No, it doesn't work. So let's look at B. B says x squared. All right? First of all, x squared, parabola, does not have a true inverse that's a function. Why? It doesn't pass the horizontal line test. But if you do, show the inverse, it's a parabola that goes this way. Does it pass the vertical line test? No. This also does not work. They are one and the same. Letter C, believe it or not, is just like, is very much like, it is a function that looks like this. Whoop, whoop. It doesn't pass the horizontal line test, so we're just going to dump it anyway. The last one, letter D, is our cubic function, which looks like this. We know that cubic functions have an inverse about the origin, and they look like this. Whoa. They look like that, okay? That is the only one that works. Letter D is the way to go. The last one, number 20, is that problem that talks about the growth of the plant. Remember, find a value of height after some time. I used 2 years. Plug that value into the equations or the functions that you see, and if you get out that number of years, then you've got it made. All right, so that's more of a plug and chug idea. Plug and chug. Like I said, if you have any questions, please, please, please call, let me know before you take the test. If you don't have class tomorrow, you can come by and let me know that you have questions. If not. But if you have any questions before the test, I don't want you to lose a lot of time on your test because you have questions. So please let me know well in advance. Thank you for your time, and that's it.